Hello, folks. Welcome. So, sorry, a little bit late. Thought I'd already started the stream, but it turns out I hadn't. So, as some of you may have noticed, in the those of you in the chat, haha, you guys are correct in that there is at least one error in the test cases for the test, as it turned out. The possibly more. So there's going to be a certain amount of modification made to the test cases in post. With respect to the two arguments for the bonus question thing, yes, that seems like that's a thing that also should be modified. So while I'm fixing the test case for Shopee that resulted in a name error, which basically blacked out 2 test cases and 4 marks, I'll make modifications to that one as well, so that you only need to have the number of arguments specified in the question. You don't actually have to include the dictionary as a default argument, because it didn't expressly say that you were supposed to do that in the test question, so it's kind of unfair to have it based on that. The issue is that generating, like regenerating that feedback, auto grading, repopulation process, it's much easier to go through it the first time than to make modifications and redo it. So I'm still working on that, but yes. Yeah, that's Konstantinos, that problem that you have cited with the Shopee _no float, that was actually a version of the Shopee algorithm that I did, which was just a basic implementation of it, which did not account for the floating point, like the modifications in order to handle floating point properly. The idea with that one was that you would get a certain number of marks even if you didn't handle float properly. So that was the point of that test case. But yes. So anyway, let me just. There's been a lot of chats, so let me see if there's any outstanding issues. With respect to assignment 6, that would be let me solve the problems with test 2, and then maybe I'll take a look at it. Yeah. So this is maybe something that you may not have known about the assignment so far, but you're actually at liberty to name the parameters that a function takes anything you like. It doesn't have to be the name that's specified in the question. So if you find A6, X and Y to be kind of not necessarily the most useful names, then please feel free to modify those so that you feel they're more readable. Absolutely. And yes, Matthew, that is correct. If you MSAF assignment 6, the percentage of your grade that was allocated to assignment 6 gets distributed evenly over the rest of the assignments. Although everybody's only using MSAFs for, medical and mental health related purposes, right? You're not planning to use them, right? Anyway. I know how people use MSAFs. But anyway, it's interesting how the chat isn't really showing up on my phone, which it's supposed to be, because that's the whole point of having my phone. Anywho, good. Anywho, so, with respect to the test cases for the Shopee question, that'll be a maximum of 4 marks that you might get when I fix the test case. And with the I haven't actually looked at the test 2 to see how many of these solutions required the use of that default parameter, which it shouldn't have. And I don't know how many marks that will be, but it'll be a maximum of 4 as well. So anyway, that's test 2. I beg your patience and forgiveness with respect to the test cases. We will get things sorted out. Anyway, so with respect to that, I think that perhaps it is time to move on to our topic of discussion for today. We will be talking about databases. Now, this is actually a kind of a cool little unit, which is completely outside of the. It's kind of to the side of everything that we've covered so far, because we're actually going to be using a programming language that is different from Python. We will be using a programming language called SeQueL, or Structured Query Language. Don't worry, it's not that hard. It's definitely not as difficult as Python. I have some questions. So for the bonus question, when it says dict is not hashable, that is an error on my part of the test grader. Dict is not hashable. I don't know. I guess we'll just have to fix the test case, and hopefully that fixes your problem. SQL injection today? Yes, sir. We will be talking about SQL injection attacks, which is fun stuff. Probably not going to get to it until, well, it's at the end of the lecture slide. But anyway, so some preliminary stuff. Up to now, we have been talking about programming languages, but now we're going to be talking about databases for the purpose of one lecture. Like programming languages, databases allow us to process and store data. Oh, is there no updated slide set for today? Good question. Because this is the old slide set, isn't it? I'll see if there's updated slides available during the break. Can you teach me how to get the IP of the annoying kid that keeps killing me in COD? No. Well, no, this is more like stealing people's passwords type area. Anyway, we'll get into it. So, databases. Lots and lots and lots of people use databases. Yes, we're going to be talking about relational databases. So, in a database, you're storing information inside of a dedicated database file. And I've just completely lost the train of the slide. Yes, so anyway, when you have a database, this is an improvement over a lot of the, just storing things in a spreadsheet and that sort of thing. For one thing, you can have simultaneous access by a number of clients if this is a remote database, either locally or remotely. um, well, Matthew, if you steal my password to change your mark, then I'd say that if you manage to be able to steal my password to change my mark, you probably deserve the increase in the grade that you give yourself. Although I still would prefer if you didn't. That would constitute academic dishonesty. But anyway, so the data inside of a database is atomically updated. That is to say, all operations are performed, they're started and they're ended, and they're not allowed to be interrupted. So until an operation ends, it's not possible to interfere with the operation of it. This is what atomicity means. It's like a command to a database is like an indivisible unit of instruction. So there you go. Data is either stored or not, but never becomes corrupted, even in the case of failure. So this is an important property. Data must be structured in specific ways, for example, in the tables of relational databases. And complex queries can be written as a result if you're using a dedicated querying language, as we will be. So, relational database. Someone in the chat has already talked about this, and it's entirely possible that some of you may already be sufficiently aware of this topic, but, probably a lot of you have never seen SQL before. Data items and their relationship are stored in tables. A table is a collection of records. A record is a row. It contains objects and entries, and it has fields. For example, columns and values and attributes. So a good way to think about it is it's good to have a mental model for relating this new idea. You can transpose this new idea of relational databases on top of knowledge that you already have and I'm going to use Microsoft Excel, although any spreadsheet software does the same thing. Here's the mapping. In Excel, you can have multiple sheets in one workbook, right? Each one of those sheets is one table in relational databases. Each record in a relational database is equivalent to a row in a spreadsheet, and each field in a relational database is a column in a spreadsheet. At least if you're using spreadsheets in the conventional manner with entries down the rows and the things that those entries consist of done along the top. So let's imagine we have a let me see here. Yeah, okay. We're going to show you guys how to get it. Yes, okay. We're going to show you guys how to get it. I'll wait until we actually have those slides to tell you. So, let's set the scene. Let's establish a scenario. A video rental store. We wish to create a database for running a video rental store. We need to track a few things. All of the movies that we have available to rent, a database of customers, and which customers have rented which movies. We will therefore make 3 tables in our database: movies, customers, and rentals. So here is an example of some data which we may have for our database. This would be the movies database. We've got several movies: Casablanca, Back to the Future, Monsters Incorporated, Field of Dreams, Life of Brian, and 12 Angry Men. All of them very good movies, except for Field of Dreams, which I've not seen, so I cannot comment as to whether it's a good movie or not. So, every database has what is called a database schema. The schema specifies the names and the types of all of the fields in the database. So if you take a look at the title, the first row, relating this back to spreadsheets again, the first row in a spreadsheet contains all of the names of each of the columns. If you take that information and combine it with the data types that are in that each of these fields uses, then you have a schema. Yeah, it is. Fatfish's observation that this is essentially a Microsoft Access tutorial. Yeah, that's true. However, we won't be using Microsoft Access in this particular instance. I'm going to be using a program called SQLite, which is well, we'll get to it. Anyway, there are 5 different valid types that you can use in your schema: integers, real numbers, which are, of course, 8-byte floats, text, which is Unicode strings, booleans, which are stored as zeros and ones rather than trues and falses, and date, which is stored as a numeric value. So, our table schema for the movies table is movie ID, which is an integer, title text, genre text, and rating text. Cool. So, let's get into the nitty-gritty. Structured query language. This is a very widely used database query language. As your colleague has mentioned, Microsoft Access also uses SQL. In fact, you would probably be hard-pressed to find a sort of mainstream database software that does not have at least some compatibility with SQL. It was first proposed in 1974 for Codd's relational data model from 1970. It can be used to interact with a database. Number 1, it can fetch a set of records. It can add data to a table. It can modify data. It can delete data, and it can do a lot of other things besides. The syntax is, for the most part, independent of the vendor. So it doesn't really matter what software you're using as a a front end, actually, pardon me. It doesn't really matter what the software is that you're using to access the database. It will be the SQL that you're going to learn during this lecture is going to be either completely compatible and exactly the same, or sufficiently close that you can figure out what the differences are and go from there. So, SQL also supports transactions, such as begin, commit, rollback. It can support authorization, stored functions, and other such things. SQL is more general than the examples that we have in this particular slide set suggest. For example, the result of one SQL query may be the input of another one, so you can chain them together. And recently, NoSQL databases for storing differently structured data and cloud storage are becoming popular. You guys have all heard about cloud storage, I assume. It's a more general purpose sort of thing where you can store files themselves rather than having to have everything into database type structures. So, there are many database programs which you might use, which are available, which you might even have installed on your very PC at this very moment. Oracle, Microsoft SQL Server, or Microsoft Access, and those are the commercial ones. And you can also get MySQL / MariaDB, PostgreSQL, SeQuelite, and MongoDB, if you're interested in the open source stuff. Most use SQL for interacting with the database, although some have slight differences. We are going to use SQLite. So, SQLite is a widely used serverless relational database manager. So SQLite, the difference between this and a lot of the more, grown-up versions of SQL, I guess you might say, is that SQLite is for accessing a database that's local to your system, in your file system, not necessarily off remotely in the internet. Although I'm sure that there are examples where it is used for that. You don't have to run any additional background services, so you don't have to hook anything up to localhost or anything like that. For instance, when I'm running Jupyter, you'll notice in the URL for Jupyter, it's running off of localhost 8888, which means that a local server instance has been spun up by Jupyter on my own local machine to be able to run a Jupyter client in it. In SQLite, you don't have to do that. It's not as good or efficient for large databases, multiple users, the more like industrial strength applications, if you want to put it that way. But it is simple, easily installed. It will run on a potato, and it's sufficient enough for you to get a taste of what it's like to write SQL queries, and that's good enough for this course, because this is not a databasing course. This is a for your interest sort of thing. And before you ask in the chat, just because I've described this as being primarily for your interest does not mean that I am not going to put a question or two on the exam about SQL queries. They make like a really good like short answer type question, an SQL question. Like write a query that does this, and it's like chuk, 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 and it takes you like 10 seconds. So, SQLite is pre-installed on Mac OS and Linux, as well as with Python, or it can be downloaded at sqlite.org. If you choose to do that, it would have been great if it loaded right when I attempted to, or pretended to punch the screen. Okay, so if you go, this is the SQLite database. If you go to download, and you go to precompiled binaries for Windows, if you're using Windows, then I recommend getting this one. Where is it? Yeah, a bundle of command line tools for managing SQL databases, including command line program, and etc., etc., etc. This is the one I would get, but select one according to your operating system, folks. Once you download that, boop, you get the following three applications. You can see I have some databases already. So when you execute, the one that you'll want to execute is sqlite3.exe. And when you run that, you get this guy, an SQLite terminal. Hello. Near hello, syntax error. So we can see that this is a friendly programming language already. So when you have the SQLite command line open, if you want to quit, well, first of all, if you want to load it from bash, you can call SQLite 3 and then the name of the database that you wish to open. And if you want to exit, it's .quit. There you go, and you can see that automatically killed that. I'm just going to reopen it. And of course, it has decided to... There we go. So, in order to well, there's actually a step that we're missing here. You have to be able to open a you have to open a database before you do anything with it. So open, I think this is how it works. Yes, use open file name. There you go. Movie store 2.db. There we go. Question: is the Avenue gradebook an SQL database? I don't know. They don't give me sufficient access to it to be able to formulate SQL queries for it or anything like that. Everything is through this, graphical user interface, which takes entirely too long to do anything. But it would not surprise me. It would not surprise me in the least if it was a database using SQL. I know that you can't export it as a database. You can only export it as a CSV, but, them's the grapes, I suppose. So, if we want to create a table inside of SQL, this is how you do it. My goodness. Am I going to be able to... Yeah, there we go. Excellent. You type create table movies, and then you enter the schema. Whenever SQL, for whatever reason, they insist in this set of slides on using capitalized keywords, but you don't actually have to capitalize your keywords. So movie ID integer, comma, title, text, comma, genre, text, comma, rating, text. And unlike Python, everything has to be terminated with a semicolon. There we go. So, we now have a movies database. Select star from movies. And there's nothing in there. But it didn't give us an error, because if we try to select from a database that doesn't exist, I'm pretty sure it won't work. Yep, no such table. Yerp. So movies is a table that does exist. Ta-da! So we also have a couple of different types of columns. So an interesting thing with SQL databases. Okay, sometimes I call it SQL. Sometimes I just call it SeQuel because it's, S, Q, and L form the word SeQuel if you add some vowels. So, so when you're making a relational database of this type, it's interesting because it's not actually required that an entry in the database contains values for every field. You can leave some of the fields out. But if you absolutely have to have some fields, like an entry is not valid if it does not contain these fields, then you would use the required keyword in front of it. And if you want to make a particular field a primary key, which that makes it like that makes a particular field the primary point of reference for cross-referencing tables. Then you would use the keyword primary key after the declaration of the pardon me, of the field in the schema. So if we wanted to drop table movies, that actually deletes the table. Be very careful with drop, because it will delete it regardless how many things are in it, or whether you want the data that's in it, or anything like that. Drop is like RM in Linux. You should always be very careful when you do it. Good. Thank you. I just got the bless you from chat from the last sneeze, and I just sneezed again. You ever sneeze and it like pushes everything out of your brain? What was I talking about? Ah, yeah, I was going to recreate the tables, but with these new keywords. So, create table, movies. Oh, and since this is a command line interface, you can just press up to get previous commands, which is cool. So, movie ID integer is going to be a primary key. Is that why mic drops are so epic? So we're going to say that the title of the movie is required. So obviously, no movie, like every movie, needs a title. Although some movies might not have a rating, or it might not make sense to give them a genre or something like that. So there we go. We have created a movie database with both a... Wait a second. Did that even work? Movie ID. Huh. Alright. Maybe that didn't work. Give me a second here. Drop table. Create movie primary key. There we go. And required. Good. That should work. Okay. So now that we have a table, let us learn how to insert data into a table, because an empty table is not much good to anyone. So we use the insert keyword. So insert into movies is the database. So you use the name of the table name. You have to specify which table that you want to insert the data into, and then you have a series of basically you enter in the data in the order that it's in the schema. So, for example, we've got 101, which is Casablanca. It is a... Let me see here. Do I have to... I think I have to include things in quotes, though. That would make sense. It is a drama romance. And it's rated PG. There we go. Oop. Syntax error. What? That's fake news. Oh, yeah. So, in order to actually enter the data in, you need to put the values keyword afterwards. There you go. So you don't actually have to specify. This syntax that they're giving you in the slides is actually not... This bit here is unnecessary. You don't have to re-specify the schema. It works perfectly valid if you just remove that bit entirely. So, select star from movies. You'll see in a few slides that that's just show me everything in this table. And you can see we've got 101 Casablanca, drama romance, PG. Very good, very good. So let's populate a few more fields just to get a feel for it. Insert into movies, values, 102, Back to the Future. It is a comedy adventure. Oop. And it is also PG. Been doing too much Python. I'm losing my semicolon reflex. Values 103. Monsters Incorporated. It is an animation comedy / Pixar. I think Pixar deserves its own genre at this point, don't you? And it is rated G. We've got movie number 104, Field of Dreams. I'm going to intentionally leave I'm going to leave the rating off this one. Just to show you that that works. Whoop. 4 columns, but 3 values. Okay, well maybe it doesn't. There we go. And entry number 5793. Life of Brian. It is a comedy, religious, and it is definitely rated R. And insert into movies, values, 7442, 12 Angry Men, which if you haven't seen it, is actually an old black and white film about people deliberating a murder trial. It's very, very interesting. It's I think the whole movie occurs in one room, but I could be wrong about that. It's very good anyway. Haven't seen it in years. Select star from movies. And there you can see there is our database. Ta-da! So, in order to get data back out of a database, you have to specify a couple of things. Which fields to return, which table you want to return them from, which rows you wish to select, and what order you wish to sort them in. Not all of these things you don't necessarily have to give answers to all of these things. But the more you include, the more specific your search becomes. So, and that's really, I think, the best way to think about this as a database search. So select, let's say, movie ID and rating from movies. Pardon me. There you go. It's showing you just the movie ID and the rating. So, of course, the asterisk is the wildcard character. When you use the wildcard character to indicate which fields you wish to display, you get all of them, which makes sense. If you wish to select just the comedy movies, select star from movies where genre equals comedy. None. Ha. How about drama? There we go. So, the where keyword, that indicates I am starting a condition. This is a filtering condition. So, it will only return database entries which match the specified condition. In this case, genre is equal to comedy. Now, in order to, in a regular programming language, double equal sign is usually used to indicate is equal to. This is to distinguish it from the equal sign, which means assignment, because equal sign means assignment in most programming languages. In SQL, we don't actually have to specify. We don't have to specify the second equal sign because there's essentially no assignment operation which uses an equal sign, so there's no conflict there. So equals can just mean is equal to in the way that it does in regular mathematics. So where genre is equal to comedy, we could also do something like where genre is equal to comedy and rating is equal to PG. There you go. And if we change that to something like G, we get nothing. So there you go. So the next one is kind of interesting. Rather than using equal sign, which means match exactly to this string, so it will only return things where the genre is exactly equal to the string drama, we can do fuzzy matching. So if you use the like keyword instead of the equal sign, and if you include some wildcard characters inside of your string, then you will get fuzzy matching on drama. So you can see we now get all of the database entries whose genre contains the substring drama rather than being exactly equal to the string genre. This is kind of cool. So the percent signs here inside of the string operate in the same kind of a manner as a star character does when you're selecting a bunch of files at once or doing stuff like that. If you notice, file, save, if you take a look at, it doesn't actually have it, okay. If you take a look at like the save file dialog, you'll see a bunch of file extensions, and it'll be something like star.pdf, star.doc, star.docx. The star there is the wildcard character. It'll stand for any other string. And the percent signs are operating in the same manner here. So, interestingly, if you leave one off, you will get only those genres that start with the term drama, right? Because there's no wildcard on this side to indicate that there might be more string on this side. And similarly, if you include it here, then there you go. It'll just do one on the end. So there you go. There's a little bit of fuzzy matching for you. And of course, there's also order by. So if you wish to sort things in ascending order or descending order, then you have to tell it what what field you wish to sort by. So order by, for example, title in ascending order. So now we've got 12 back Casablanca field life monsters, which you can see is in alphabetic order. Cool, cool. So the next few slides just go through the same things that I've just been demonstrating to you. Which fields to return, that's select which fields you want to return. And you can use these in any combination, of course. Which table you want to specify it from is specified after from. Which rows you wish to select is specified by where. You use conditions after where to filter your database. Yes, yes, yes. You can use Boolean conjunctions in order to chain these things together. So, for example, select title from movies where rating is equal to PG, or rating is equal to G, and genre is like comedy. If the world is getting you down and you just want to watch a fun comedy with your kids. There you go. You've got two options. Back to the Future and Monsters Incorporated. When you're sorting, you don't necessarily need to specify ascending order. Ascending order is the default. However, if you want to, you can. And if you want to specify descending order, the keyword is DESC, or desk. There you go. You can see it's in reverse alphabetical order. So, that's actually a really good place to leave it for the break. See you guys in 10 minutes. Hello. Oh, picture. There we go. Hello. Welcome back. Guess what? Kitten, that's what. Hello, everybody. Say hello to Rimby. Rimby, say hello to the people. Whoop, 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 whoop. There. Hello, everybody. Are you learning all of your SeQueL databases like you should be? I hope so, or else I'm going to come and I'm going to feast on your flesh. Woo. There we go. She's so cute when she threatens to eat people's flesh. So, question, does the final exam include databases and machine learning? Machine learning, likely not. I don't think so, no. However, databases, totally fair game. And by fair game, I mean I am very probably going to put some databasing stuff on there. There'll be some writing of some queries and stuff. So, yeah. But don't worry too much about it. It's an open book exam, so you've got slides for reference. So really, anything I ask you for, you've got it right there. So it hopefully shouldn't be too difficult. I consider that to be one of the easy questions, in case you were wondering. Although I haven't actually written the question yet. I'm still in the process of creating the exam. Yeah, okay. The cat gets a blog now? Yeah. The cat's name is Marimba, as is stated previously in the chat. Yes. Yes, good luck on the MCATs. I hear that they're difficult. I've never had to write one personally, because I'm not a biologist, or a health science person, or anything of that nature. Anyway, so, getting back to databases. You may be interested to hear that it's actually possible to access an SQLite database in Python. So Python has a library module which you can access SQLite databases through. You need to specify the file name of the database, and it needs to be stored on the computer, but there are plenty of ways to access stuff remotely as well. So the way that you do this is very similar to the way that you yeah. MCAT. Yeah. Yeah, so with Marimba, the cat's names, basically my wife and I sat on the couch for like the better part of an hour just saying random words and names, and that was the one that we liked the sound of the best. And it also is really quite good for cute cat names. Most of the time we call her Rimby, or Rimbles. But anyway, enough about cats. So, and otherwise. So, the process for opening a database in Python, using Python code, is very similar to how you would do it, how you would open like a CSV file or something like that. You connect to it, which is like opening the file, and then you close it when you're finished with it. And then you do stuff in between. So let's set that up so that we can get that working in Jupyter. So let me just take this movie store 2 database that I've been working on, upload it, haboink, there we go, and then new Python 3. A marimba is a musical instrument that's similar to a xylophone. in some ways. Has a sustain pedal though. Anyway, import SQLite 3. Database is equal to connect. In our case, this is movie store 2.db. Then db.close. Let's just make sure that compiles. Does not connect, is not defined. What did I do wrong? Yeah, you need to do SQLite 3 dot. There we go. Ha! So this is good. We can open it, we can close it, but if we aren't actually doing anything to it, then we are not using it optimally. To quote a video that I watched recently, if you're not actually doing anything with your database, then your playstyle is deeply suboptimal. So, it's also important, before we get too far into this, to understand the correspondence between Python types and SQL types, data types, that is. Null is none. So in SQL, in SQL, you've got a null. In Python, you've got none. SQL has integer. Python has int. SQL has real. Python has float. SQL has text. Python has string. SeQueL has date. And that converts to a string in Python. So if you want to, for example, use that lovely date time object that we were discussing last on Monday, you're going to have to use the what was it, strp date function that there was a couple of slides on in that lecture, in order to parse out what the actual date is. And in order to construct a date and feed it back into SQL, you'll have to, do the reverse process. So, let's do selecting from Python. All SQL statements are passed as a string to the database. A cursor is needed to iterate over the results of an SQL query. So, the cursor is kind of a little bit like this cursor right here. It's like this was an object in Python. So, in order to instantiate the cursor, we need to, declare it. There we go. So, our cursor is equal to database.cursor. There we go. If we want to, for example, execute the following, select star from movies, very nominal SQL query. Notice that the entire SQL query is encapsulated in quotation marks. This is a string, so this string represents programming code. Then we can print cursor.fetch1, and we can also fetch all. So if we fetch 1, we get a tuple containing the first entry. So this operates in very much the same manner as reading lines out of a file. When you ask for a line out of the file, it's like, okay, I have read you the first line, moving the cursor. And then if you read that one, it moves the cursor again. And if you ask for all of it, it just gives you the rest of the results of your query. If you call fetch all, it gives you the results of your query in the form of a list of tuples. List of tuples. That's very important. So, cool. This is good. Boop. No. There. That's better. So there we go. Interestingly, we can also get that via a different mechanism. We can get the results. The results of the query are also returned from the execute method, and the results of the execute method, we can actually get the type. That might be interesting. Class SQLite3 cursor. It's actually iterable as well. So we can for loop over them, for row in rows. Our classic Python notation, print row. And there you go. There are all of our rows of our database. Yes. Well, we can try it, but I don't think that we'll get anything. Execute order 66. Yep, operational error. So this is what it looks like when it's telling you that your SQLite code is invalid. It gives you a quote-unquote operational error. And since we know how to deal with those using try-catches, this does not scare us. Select star from movies. There we go. So, if we add the following line in red, the rows we get back will be dictionary-like objects where we can pull out a field by name. So, db.rowFactory is equal to SQLite3.row. There we go. Boom, boom, boom. So if you wanted the title, there you go. Very cool. So that might be useful. It turns things into dictionaries. So we can insert stuff into Python, insert things into the database from Python as well. So if we wish to add the following, and this is where you start getting into the interesting expressive power of Python, right? So let's imagine we had a movie ID, a title, Beauty and the Beast, a genre, animation, musical, comedy, romance, because that is certainly a romance before pretty much all of the rest of those. Rating is G. We can insert into movies values kicked me off for a moment there for some reason. Okay, I think we're back now. Are we back? Hello, world. Is it cool? Are we cool? Okay, good. Sorry about that, folks. Where were we? Cool. Anyway, when we have these little question marks here, what's going on there is these are holes that are being left in this string, which they are populated with the values which you provide in a tuple as the second argument to execute. So M is going to be put in the first hole, T in the second hole, etc. We're going to be discussing why this is a very important thing to do. Why, one might ask, why don't you just, plug these in directly? And we're going to get there. So if we do that, cur.execute, well, we'll get rid of rows, and then cur.execute select star from movies. Programming error. Cannot operate on closed database. Oh, yeah, okay, I get it. I know what I did. There we go. So you can see that Beauty and the Beast has been added to the database. Ta-ra! This is cool. And I'm just going to comment that guy out. Once we have, if you're going to make changes to the database, it's fine, but if you'll notice, every time we run this, we get the same list back out of it, right? If you notice, this isn't being saved, right? It's adding it, but as soon as we close it, you have to save it too. Like if we were to take out the database right here, right, and can we look inside of it? Nope. If we take this database and we download it, boop, let me just put it here. Let me just put it here, man. Let me just put it here. Let me just put it here, man. Yeah, replace it. Oh, yeah, I need to quit this first. There we go. Continue. There we go. SQLite, run it, yep. Open movie store 2.db. Select star from movies. You can see that it's not in there. I know I probably didn't need to take that long to show you that it didn't save. But the way you do it is db.commit. Or is it cursor.commit? Let me see. It's cursor.commit. There we go. Well, anyway. Operational error. Database is locked. Probably because I didn't wait for it to finish. Well, let's see. Oop. Okay. Now. Okay. Fine. Be that way. Shut you down. I'm going to destroy you. There we go. Hmm. Well, that's interesting. Anyway, I'm not quite sure what's going on there. Maybe it's db.commit. That seems to work. Okay, so that's a typo in the slides then. Integrity error. Unique constraint failed. Ah, yep. So, it won't let us enter a second instance of Beauty and the Beast in unless we, because the primary key has to be unique. So, that's a constraint. There we go. We figured it out, folks. We figured it out. So, okay. So this is fine. This is good. This is all well and good. But let's imagine that we wanted to actually come round back to the application that we talked about at the beginning of all this, which is keeping track of who's got what movie rented. So let's create a couple more tables. We're going to create a customer table with the following fields: customer ID, name, and address. And we're going to create it according to the schema. And we're going to create a hello. My goodness. We're going to create another one, which is a table of rentals. So there. So let's go back to our database here. Boing. There we go. Dot open movie store 2.db. There we go. Create table. Customers. Customer ID is an integer primary key. We've got name, text required, and address text. Because you have to have a name, but you don't necessarily have to have an address. Because we are fine renting to people of no fixed address. There you go. Let's now populate it. Insert into customers, values, 101, Dennis Cook, which has to be quotationized. who resides at 123 Boardwalk, because that's also a typo. We shall have 456 Park Place. Doug Nickel. Oop. Meh. I'm just doing some data entry. St. James. I'm telling you, folks, this is your life hacks with your professor for the playing of the board game Monopoly. If you get the orange, you're automatically going to win. That's how Monopoly works. The orange square, the orange color group, is the optimal, it's the optimization point between investment cost in houses and the amount of money that you make off of it when people get hit by it. The oranges are the superior color group. The other thing is they're extremely high probability of being hit by people who are coming out of jail. So if you're ever playing Monopoly, always go for the orange color group. Should be St. Charles Place. There we go. So select star from customers. And there's our database. Fantastic. Cool. Now, let us create a movie rental relationship table. So this is a table that will tell us who's got what. So, create table rentals. The schema is customer ID, integer required, movie ID, integer required, date rented, date, and date due. Date. Date is kind of redundant there, isn't it? Cool. Insert into rentals, values, 103, 104, 3-12-2020, sure. 3 dash. Wow, rented for 1 day? Let's give them a week, shall we? 2020. (103) has also rented 50/22 on the 23rd, sure. and is due on the 30th. $105, $107, and you guys can see how you might rig up a program to be able to do this automatically, right? Like generate these queries. I don't know how I feel about exploiting people who just got out of jail for money. Well, it depends, man. If the people who just got out of jail are hell-bent on your financial ruin, then perhaps it is justifiable. I mean, the point of the game is, after all, to be a ruthless capitalist. So if we select star from rentals, we've got our rentals database. Fantastic. So now let's talk about working with these relationships that we've now established. If we select the rentals table, we only get the customer ID and not the customer's name or information. And we also get the movie ID, but not the movie name or anything like that. Naively, we would have to do an extra select lookup to look up each customer one at a time. But we are provided with a way to do all of this at once because we are working with a relational database. So, select star from rentals and customers. That's right, folks. You can specify more than one table. Where customer ID. Notice we're using dot syntax is equal to rentals dot customer ID. Oop, no such column. Customer. Oh, yes. There. So, notice game of life is equal to or greater than Monopoly. Let's see. Monopoly is anything goes. Friendships don't count here. Yep. It's like saying, oh, I'm not going to use the blue shell. Yep. I mean, you gotta use the blue shell, otherwise your whole item spot is locked for the rest of the match. The 2020 version of everything sucks. I think that's yes. It's monopoly capitalism can't exist without exploitation. Oh yes, that sweet, sweet exploitation. Yeah, hold on to the blue shell until you're in first place and then throw it at yourself. Yes. Har har. Anyway, so you may notice that with this relational database, what it's now done is each entry in the database includes all of the information for the customers. So it's matched up all of these. It's matched up all of the customers to the correct customer IDs and then given that out. However, the way that it does this is a little bit strange. So let me show you something. What happens if we remove the filtering constraint? Oh boy, that's a lot of stuff. So what is actually going on here is it's saying it's basically taking each person, right, and it's matching it up to each relation or each entry in the relation in the rentals database. So each entry in the rental database gets iterated once for every entry in the customer database, and it runs them together. So basically, this is like a multiplication operation, right? Then we filter that down to extract only those entries where, in this particular example, the customers dot customer ID is equal to rentals dot customer ID. There you go. And if you want, you can, of course, narrow down what you are viewing. Customers dot name, I think. There you go. These are the people who currently have movies out. So there you go. Some database stuff using relational databases. So the result is a single table that forms as if we had joined the two tables together where they match, where they have the matching field. This is also called a join operation or an inner join. You can, of course, add all kinds of different constraints to this. So if you want like the mega list of all rented movies, we would have select star from rentals, customers, and movies, where customer ID is equal to rentals.customer ID, and rentals.movie ID is equal to customer movies.movie ID. There we go. And there you go. You can see that it has, in fact, plunked. Well, we've actually got only one database entry remaining, which is interesting. But the reason for that is that the other rentals had movie IDs which weren't actually valid movies in our list of movies, so they couldn't match against anything, so they don't appear in the list. There we go. So that's cool. That's some database stuff. Ta-ta-ta-ta. So here are some other useful but somewhat dangerous commands. We can update entries. Up to now, we've just been creating entries and assuming they were good. But here are some editing commands. You can update movies. You know what? I'm going to just take a backup real quick. There we go. Update movies. We want to set the genre equal to horror and the rating equal to R, where title is equal to Monsters Incorporated. And if we take a look, select star from movies, you can see that Monsters Inc. is now a R-rated horror an R-rated horror film. But this is dangerous. You have to be careful. If you don't include the where condition, then you run into a problem. Oop. Oh, this was, yeah, okay. I did a boo-boo. Update movies, set genre equal to horror, and rating equal to R. You can see that this command sets all of the movies to R-rated horror movies. This is presumably bad because you have essentially wiped out all of the genre information for all of the movies in the database. And you either have to A, load a backup copy that you kept, or B, re-enter all of the information you didn't mean to get rid of. This is Linux rules. They're assuming you know what you're doing, so there's no undo. No undo. So that's bad. You can also delete stuff. So, again, same problem with where if you omit where. You can delete from movies where movie ID is equal to 104. And you can see, entry number 104, which was Field of Dreams, has been removed from the database. Again, if you forget the where, it will delete every row in the table, and there's no undo. Backup frequently. Has anybody else come across the database error file is encrypted or is not a database? Because I've been figuring out how to deal with it and gotten nowhere. Are you getting that in Python or in SQLite 3? The most dangerous command of all, of course, is drop table. Drop table will delete a movie entirely, or deletes a table entirely. So if we try to get something from movies, it doesn't exist anymore. In Python, you say. So, it's, I don't know. Like, the thing that I did was I created a database using SQLite, the local installation, copied that over, and then was accessing that from within Python. So, it's possible that that's the problem. I would recommend, to see if that's the problem, try downloading SQLite and making a database, and then whoop, I'm just gonna get rid of you. Quit. I'm just going to yeah, okay. If we're gonna drop an X-Men movie, then why won't we drop the new one, like the last Wolverine one, where it's so depressing that it's like, woof, why did I even watch this? I feel like the database never saved properly in SQLite. So it's possible that let's take a look at that. Let's see if we can make a database from nothing, shall we? So, shoop. Just gonna make like an easy one. Mario DB. Don't worry about that. Create table Mario games. Schema name text and year integer. Why not? Then cur.execute insert into Mario games, values, Mario 3, 1988, I think? Or was it 91? I think it was 91. Good, okay. Hmm. Hmm. Am I forgetting semicolons? I think that might be an issue. Maybe they add them in. Ah! There we go. My goodness. Okay. I think that we all have to agree with Kylo Ren that Darth Vader was the coolest. I think that's maybe the least controversial thing I can say about Star Wars is that Darth Vader was the coolest villain. Anyway, so I just did all of this and it seemed to work just fine. I'm not sure what you guys with your database error file is encrypted or not in database. I'm not sure what that is all about or what, but like Mario.db was not a database file that existed before I connected to it, so I don't know, man. I don't know. Yeah, Darth Maul was pretty cool too, but mostly in terms of like visual design rather than he didn't really say much, you know. He was like almost like this, you know, this like voiceless force of nature. Whereas like with Darth Vader, you got the definite. I feel like you got a more of an impression that he was like an intelligent, terribly vicious thing coming after you. You know. Anyway, um, the problem I had was when I made the database in SQLite and then tried to access it in Python. Maybe you need to close the database, quit the database, save the database, do whatever with the database before you load it into Python. Maybe. Anyway, that is our yeah, like a Phantom Menace. Yeah, very very good. Yes, indeed. Time to watch the Clone Wars. Yes. Yeah, probably. I don't know. I've been watching World War II in color lately, and that's a really cool thing if you like history and stuff. Anyway, um, yes. Anywho, break time. See you guys in 10 minutes. Okay. Welcome back, folks. So we just talked about, before the break, we were talking about how to delete everything. Be very careful when you delete stuff. There's no undo. So here's a question. What if you allow the user to input a query? So, for example, let's say let's copy that. Let's work this into our movie database script. Let's get rid of this stuff. There we go. So, in this one, expected indented block. Oh. There we go. So, if we create a little bit of user interaction, enter a rating you'd like to search for. PG. And there's all the PG movies. This seems to work pretty well, right? Here's a question, though. What happens if, get out of here, you. What if our string is invalid, right? Let's say it's gloop. We get nothing, right? Or what if it's something like that? Still nothing. However, what if we start messing around with quotes? So let's say parental guidance in quotation marks. Well, we get an operational error. Guidance is, in fact, considered to be a keyword that you're going for here, rather than a search term. This is bad. This is super, super bad. This is what we're going to be talking about now, why this is bad. This causes an error. But if we're clever about it, it can cause a lot more than just an error. So, watch this, folks. Let's say PG and then semicolon, and then insert into movies values movie ID 10, how about 1337, Hackers World. The genre is none ya business, and the rating is wouldn't you like to know? You can only execute one statement at a time. Ha! That's the thing. There you go. But the issue is that you can actually, if this is a sufficiently unprotected thing, then you could, by terminating the string before it's intended, you can actually enter full SQL code into these sorts of things. It would be tacked on to this guy. Now, it didn't work. It didn't quite work as I'd hoped. But a good one is you can actually expand the search criteria. So let's say we wanted to search for PG, or X is equal to X. Now keep in mind it's going to add another thing there, right? So there you go. We have accessed not just the stuff that's PG, but everything in the database. It's missing a right bracket after PG. Oh, okay. Let's see then. Well, I don't think it is, but anyway, it doesn't allow execution of multiple statements for exactly this reason. So this leads us to our next topic, which is SQL injection attacks. When user input is mixed into a query string, such as in the previous slide, this makes applications vulnerable to SQL injection attacks. This can occur when the attacker injects their own SQL commands as a string that gets accidentally executed by the database. These can be used for many purposes. It can be used to access more data than the user is intended to be able to see. It can be used to trick login checks and gain access to people's information without knowing passwords. It can be used to access databases from other tables using join commands, or it can sometimes even be used to modify or delete data. So, let's see if we can try to do that then. So, PG or X is equal to X. X equal to X always comes out to true, of course. Join rentals. Maybe that'll work. Syntax error. Okay, so I don't actually know how to use the join command. Anyway, so what if the user enters the following? Delete from movies where X is equal to X. Well, fortunately, cur.execute will only execute one command and will complain if there are multiple commands, which, we have seen. So execute is, it checks for it, and it does things in a safe manner. So, but of course that's been built into it, right? However, there is, of course, the execute script method, which performs no such checks. So, if we modify this, because execute script is intended to execute multiple multiple lines, right? So if we then do PG end statement, and then you could literally do anything. Select, stop, you could do insert into movies values 0 dumb dumb dumb. And then we should probably just so we can see what's going on, throw that in there. I didn't close it. Do you need semicolons to enter your pseudocode into the SQL database? Yes. So in SQL, like in most programming languages, the semicolon indicates a line break. So if you're trying to inject extra lines in, which is a thing that you would want to do if you were a hacker, you will you'll need to use the semicolon. However, you'll need to also enter a rating you'd like to search for, PG, and then insert insert into movies values I think 0 x y z. The cat's meowing at me. Unrecognized token. Yeah. So, or we could do something even more insidious. We could, because the problem is that it has to correctly end on a double quote here, right? So we could do update. What was update again? Let's see here. Yes. Update movies, set title equals. Yeah. Neener, where x is equal to x, and you leave off the last quotation mark because that's going to be inserted here, right? So there we go. We have entered it, and probably if we take a look, let me just grab that copy. If we then make the further mistake of db.commit right there, there we go. And if we take a look at the shoot. Ha! There we go. See? Everything's been replaced. Da-da-da-dum. Successful injection attack. There you go. So you have to, like, because it's ending on a quotation mark, you have to format the injection attack so that the there's a missing quotation mark at the end. But there you go. So that's how that can work. So this is to illustrate the dangers of using undone things. Oh yeah, and double dash is how you start a comment. So if you put a comment at the end of your injection attack, then you don't have to worry about ending it with a quotation mark. But you can see how this can be very destructive. So here's a little comic from the very famous computery sciencey web comic XKCD, which if anybody doesn't read XKCD, you should. So, hi, this is your son's school. We are having some computer trouble. Oh dear, did he break something? In a way. Did you really name your son Robert Drop Table Students? Minus minus? Oh yes, little Bobby Tables we call him. Well, we've lost this year's student records. I hope you're happy. And I hope you've learned to sanitize your database inputs. Yes. So there you go. There have been a number of injection attacks over the years which have been extremely successful. So let's take a look at a few of them, just to contextualize things. SQL injection attacks are the #1 security threat to web applications, according to the Open Web Application Security Project. Many large-scale breaches are due to SQL injection attacks. For example, Yahoo had close to 500,000 login credentials stolen in 2012 using a join-based SQL injection attack. And many more attacks are listed on Wikipedia, which we shall wiki look at. Burp, burp. There we go. Gotcha. I caught her again. Yes. Yes, XKCD does have a relevant comic for every one of life's little situations. Oof. I caught you, but you were in a playful mood. I put you on my head. There. Is it easy to track if someone is doing an SQL injection attack? I guess obviously there are a certain degree of precautions that people take against this type of thing, since, you know, it is the #1 security threat against web applications. So generally speaking, when you make a request or send something to a server, there's a record of what was sent and who sent it. Now, if you're like spoofing your IP address and, you know, using virtual private networks and doing all kinds of that kind of stuff to cover your tracks, then, you know, possibly you could have, you know, a decent degree of covering your tracks. But Equifax. Let's see. Equifax. Well, it's not in this Wikipedia article, but it's entirely possible. I'm not sure about that one. I haven't heard of that one. So let's see here. October 2015 and execute. Yep. So 150,000 customers from. goodness, a British telecom company. Theft of confidential information from roughly 420,000 websites using SQL injection attacks. Biomedical engineering servers at Johns Hopkins University. United Nations Governance Forum. A hacker group called Team Ghost Shell published personal records of students, faculty, and employees and alumni from 53 universities, including Harvard, Princeton, Stanford, Cornell, Johns Hopkins, and the University of Zurich, on pastebin.com. The hackers claimed they were trying to, quote, raise awareness towards the changes made in today's education, bemoaning changing education laws in Europe and increases in tuition in the United States. I guess. Sure. Anyway, there's a whole bunch of them. The British Royal Navy website was compromised by a Romanian hacker. So there you go. In May 2008, a server farm inside China used automated queries to Google's search engine to identify SQL server websites which were vulnerable to the attack of an automated SQL injection tool. My goodness. Yeah, so this is serious biz. Serious business. So there are a couple of ways to avoid making your code vulnerable to SQL injection attacks. The first one is to use execute rather than execute script. Even if you want to execute multiple lines, you can just have multiple execute calls. You can also sanitize user inputs by filtering out single and double quotation marks or other prohibited characters. They're giving you your string, so you can just check to see if there are any comments or semicolons in it, and reject it, I suppose, if you consider it to be an illegitimate query. However, this using a question mark as a placeholder, that automatically binds the query in a safe way. It automatically performs the types of checks that are necessary in order to sanitize your inputs. So that's like the Python automatic way of doing things. But anyway, that's the last slide. So that's everything we have to talk about with respect to databases. Very cool. We have roughly 25 minutes left in class, so I guess I'll open the floors to any questions that you may have for me, your professor, on this, the eve of tomorrow. Anyway. Well, if nobody has any questions for me this evening, then I will, I guess, log off for today. I'll give it a little longer in order to allow people some time to get their questions in if they have any. Is there going to be an SQL question on Python on exam? So there will be very probably an SQL question on the exam. They make a really good like warm-up question, in my opinion. If you see a question on the exam that is an SQL thing, it will likely be of the form write an SQL query that performs X function, where X function might be gets all of the all of the values of this particular thing in a database or something like that. Like know how to do select, know how to do insert, that sort of thing. Needless to say, the majority of your final exam mark will not come from SQL related questions. Well, I'll give it another minute or so before I'll log off, just in case anybody has any questions, comments, concerns, philosophical problems. Okay. Well, that'll be enough for me for this evening. Thank you very much for your time and attention, folks. And when we resume, so this is what the schedule for next week's going to be. Monday we'll be having the lecture on machine learning, which is fun. I may not get through all of it on Monday. I usually don't get it through it all in 1 week/day. But if I don't, then we'll continue it on Wednesday. But Wednesday will probably mostly be a Q&A session with me, your prof, about the exam, study session for the exam. So please prepare some questions to ask me. Is there a practice exam? I'll look in the archives and see what I can pull up. Yeah, I think so. Anyway, yeah, that'll be everything for this evening. Thank you very much, folks. Yeah, I know. It's crazy how fast these summer courses go, right? But yeah. Yeah. Pretty soon you'll all be fully graduated first year Python course graduates. But yeah. Yeah, to be honest, oof. I don't know. I don't know what I'm going to do when I don't have any teaching left to do. But we'll see. I'll figure something out. Take her easy, folks.